Welcome to HDIN Research's strategic deep dive into the global high-temperature superconductivity (HTS) industry. Our analysis for 2025 focuses on the pivotal shift from laboratory-scale demonstration to large-scale industrial commercialization. We will examine how this technology is currently bridging the gap to become a critical component of 21st-century infrastructure. We begin with the executive overview. The industry is currently in a, quote, 1 to 10 feet expansion phase. While 2G HTS technology has reached technical maturity, the current focus is on cost inflection and yield optimization. Driven by sectors like nuclear fusion and AI data centers, HTS is transitioning from a niche material to a strategic industrial asset. To understand the market, we must look at the physics. While the traditional BCS theory successfully explained low-temperature superconductors, HTS materials like cuprates break the Macmillan limit. This theoretical breakthrough allows for superconductivity at liquid nitrogen temperatures, which is the fundamental driver for reducing operational cooling costs. The history of superconductivity is marked by threshold breakthroughs. Since the 1986 discovery of YBCO, the industry spent decades in the materials R&D phase. As of 2024, we have entered the commercial deployment era, where annual production capacities are finally meeting the kilometer-scale demands of the energy sector. Technically, the industry has pivoted from 1G BSCCO to 2G REBCO. 2G HTS offers superior magnetic field performance and lower silver content, which stabilizes the cost structure. Various deposition routes like PLD and MOCVD are currently competing for dominance, with PLD leading in high-performance applications. The value chain is structurally hierarchical. The most critical node is the midstream tape manufacturing, which currently commands the highest gross margins, up to 40% for market leaders. Upstream stability in substrates and downstream integration in fusion magnets are the primary anchors of this ecosystem. However, the transition to mass production faces complications. Scaling from meters to kilometers requires extreme uniformity in critical current. While tape prices have dropped significantly, approaching the $100 per kiloamp-meter threshold, long-length stability remains a key engineering challenge for manufacturers. Beyond the tape itself, supply chain constraints persist. While liquid nitrogen has replaced helium in many HTS applications, the reliance on specialized alloys like Hastelloy and the complexity of cryogenic system integration represent significant barriers to entry for new players. Geopolitical dynamics show diverse strategic approaches. China and Japan prioritize full supply chain autonomy and manufacturing scale, while the US and UK focus on milestone-based funding for private fusion ventures. Despite different models, all major economies have now categorized HTS as a strategic frontier material. The central question for 2025 is, how do enterprises move past the inflection point? Success now depends on three factors: factory yield management, raw material security, and deep integration with emerging high-growth sectors like AI and fusion. Our benchmarking reveals a concentrated landscape. Shanghai HTS and Fujikura lead in technical parameters and production volume. Meanwhile, players like AMSC have successfully shifted focus towards system integration, demonstrating that value can be captured at multiple points in the chain. Shanghai Superconductor represents the, quote, efficiency model. By achieving a 1,000-kilometer annual capacity and high yields, they have secured over 80% of their domestic market. Their shift to profitability in 2024 marks a milestone for the entire industry's commercial viability. In contrast, AMSC is leveraging its position in modular power systems for naval and grid applications, while Fujikura maintains a, quote, manufacturing excellence profile, supplying critical components to international projects like the UK's STEP Fusion initiative. Lianchuang Opto exemplifies the application frontier. By integrating HTS into MW-class induction heating and silicon furnaces, they have proven that superconductivity can provide immediate energy-saving ROIs in traditional heavy industry. Financing in this sector is characterized by conservative leverage and high R&D intensity. While leaders show healthy ROEs, the industry still faces, quote, lumpy revenue cycles tied to large project deliveries. Investors must distinguish between pure-play material science and integrated system providers. Our SWOT analysis highlights that while tape manufacturers have a technical moat, they are sensitive to downstream delivery cycles. Conversely, system integrators enjoy higher premiums but must manage the high bill of materials cost of the HTS tape itself. The innovation versus growth radar shows that while technical innovation is high across the board, the quote growth axis is currently being led by those who have secured long-term contracts in the fusion and grid sectors. Nuclear fusion remains the single largest demand driver. HTS allows for higher magnetic fields and smaller volumes, which is the only viable path to making fusion reactors commercially and physically compact enough for power plants. A new growth frontier is the AI data center. As rack power densities reach 200 kilowatts, HTS cables offer 10 times the power density of copper. This allows operators to scale compute capacity without expanding the physical footprint of the facility. In conclusion, the capacity outlook for 2025 is dominated by East Asian manufacturing hubs. As global demand for magnet-grade tape surges, we expect the market to reward players who can maintain high yields at 1,000-kilometer scales. Thank you for reviewing this HDIN Research Industry Dive. If your organization requires deeper market data, customized feasibility studies, or technical audits, please contact us at sales@hdinresearch.com. We look forward to supporting your strategic decisions.